Okay, so for these type of problems, you're always going to draw a free body diagram first with the vectors. They're a little tricky when they're on an angle. I'm going to go ahead and tilt my axis so that the acceleration or deceleration down the ramp is on the x-axis. So anything perpendicular to the x-axis, or excuse me, to the ramp, would be the y. So I have the normal force because the car is in contact with the ground, the weight because it's on earth, and then there's friction opposing the motion. So all of those, the friction and the normal force are both on my new axis system, so I'm going to go ahead and break my weight into components. And you could do similar triangles. If this is 6 degrees down here, then this is 6 degrees here. So sum of the force in the x equals max, so I'm going to have wx in what I'm going to call the positive direction, minus f sub s equals max. In the y direction, I'm going to have the normal force up minus w sub y down equals 0. 0 because since I tilted my axis, there's no acceleration in the y direction. The car is not floating or sinking. So n equals w sub y. Instead of w sub y, I'm going to put mg cosine 6. Now what's a little tricky is really you need to go back into your chapter to find the coefficient of friction that they give you in a table, 5.1. So they have dry concrete is mu sub s equals 1 and wet concrete is mu sub s equals 0.7. So taking this previous equation, instead of wx, I'm going to write mg sine 6 minus f sub s is equal to mu s times the normal force, and the normal force up here is mg cosine 6. So I make two substitutions right there, equals ma. This is why the mass doesn't matter, it cancels out. And then we do some plugging and chugging. Now I got acceleration is negative 8.72 meters per second squared, and WebAssign is looking for 8.72, and I'm guessing that that's because of the wording of the problem. They've already said it's decelerating, so they're only asking for the magnitude. I thought that was a little confusing. On the next problem, everything's basically the same except for your value for mu. Again, you're going to get this negative 5.8, and WebAssign is going to want a 5.80 meters per second squared because they've already talked about deceleration. And then the third value for mu, the 0.1. This time, actually, when you do the calculation, you get a positive value, and so you're going to need to put a negative value in when you put this into WebAssign. Thinking about what that means when there's so little friction. All right, hope that helps.